Good morning, dear student. Today I am continue to the previous lecture. I am discussing the differential equation. Now I am discuss the topic exact differential equation. Now please you can note down exact differential equation. Exact differential equation. A differential equation a differential equation is the form of m dx plus n dy is equal to 0. M dx plus n dy is equal to 0 if it satisfied if it's satisfied del m of del y is equal to del n of del x is called exact differential equation. Exact differential equation where where m where del m of del y is differential coefficient of m and del n of del x is equal to differential coefficient of n with respect to x now solution of exact differential equation. Solution of exact differential equation. Step number first. Step number first. Integrate m with respect to x where y is constant. Now step number second. Integrate n with respect to y where n contains only only y, or you can write n is not the function, is not the function of x. Now the step number third. Now the step number third. Now the step number third, adding step first and step second. You can write step first plus step second is equal to constant, or you can write integrate m dx, where y is equal to constant, plus integrate n dy is equal to constant, where n is term n not containing x. You can write this. This is a method of exact differential equation. If it satisfies this value, this means del m of del y is equal to del n of del xy is called the exact differential equation. Now, where del m of del y is the differential coefficient of m with respect to y, and del n of del x is equal to differential coefficient of n with respect to x. Now the solution of the differential equation, step number first you can find integrate m with respect to x, where m is constant. Now step number second, integrate n with respect to y, where n contains only y, or you can write n is not the function of x. Now third step is adding step first and step second, or you can write integration m dx, where y is equal to constant, plus integration n dy, the term n not containing of x is equal to constant. You can write this method. Now I am applying this method. You can note down some numericals related to the exact differential equation. Numerical number first, solve the differential equation if you can note down 2x minus y dx is equal to x minus y dy. Now the solution of this problem, we have 2x minus y dx is equal to x minus y dy. You can write 2x minus y dx minus x minus y dy is equal to 0. First, you compare the exact differential equation m dx plus n dy is equal to 0, where m is equal to 2x minus y and n is equal to minus x minus y. Now, condition of differential equation, exact differential equation, del m of del y is equal to, now the condition of the exact differential equation, del m of del y is equal to del n of del x. Now the putting the value of del of del y, m, this is your m, 2x minus y is equal to del of del x, n is this, minus x plus y. Now you can differentiate y in this function, the x is constant, in this function y is constant. Now you can write minus 1 is equal to minus 1. It means del m of del y is equal to del n of del x. It satisfied this condition, hence the given equation is exact differential equation. Now this is equation number first. Now the solution of this differential equation, integral m dx, where y is equal to constant, plus integral n dy, where term n not containing x is equal to constant. Now the putting the value of m and n, this means integral y is equal to constant, putting the value of m, 2x minus y dx plus integration. Now the putting the value of not containing of x, this means minus minus plus, you can write y dy is equal to c. Now you can integrate 2x square by 2 minus xy plus y square by 2 is equal to c. Now you can write x square plus y square by 2 minus xy is equal to c. This is your solution of differential equation. This is a solution of your differential equation first. This is a most important step for exact differential equation. Please, you can note down this numerical. This is important for your examination. Now you can note down the second numerical related to the exact differential equation to solve the differential equation if you can note down the numerical e to the power y plus 2 sin x dx plus minus e to the power y cos x dy is equal to 0. Now the solution of this problem, first you can write we have e to the power y plus 2 sin x dx minus e to the power y cos x dy is equal to 0, where m is equal to e to the power y plus 2 sin x and n is equal to minus e to the power y cos x. Now, first satisfied the condition, del m of del y is equal to del n of del x. First you can find del m of del y. You can write the value of m del of del y e to the power y plus 2 sin x. When del m of del x, the x is equal to constant, you can write e to the power y sin x. Now second is del n of del x, putting the value of m n, you can write del of del x, you can write the value of this minus e to the power y cos x, where del n of del x, the y is constant. Now you can write e to the power y, the differential of cos x is equal to minus sin x, this means sin x. Since del m of del y is equal to del n of del x, the condition are satisfied, the condition is satisfied, therefore this is a differential equation, therefore integration m dx, where y is equal to constant, plus integration n dy, where term n not containing x is equal to constant. Now you can write integration y is equal to constant, put the value of m, this means e to the power y plus 2 sin x dx, plus integration the term n not containing n, but term x is containing, this value is equal to 0 into dx is equal to constant. Now you can integrate this. First, the integration of this, you can use integration e to the power y plus 2 sin x dx y is equal to constant is equal to c. Now you can integrate minus e to the power y plus 2 cos x is equal to c. Now you can write c plus e to the power y plus 2 cos x is equal to 0. This is a solution of differential equation. This is a solution of this differential equation. You can note down this numerical. This is a step by step to solve this numerical. Now again I am consider next method of exact differential equation. Now I am discussing the equation reducible to the exact differential equation. If sometime the differential equation is not found in an exact form, you can reduce to the exact differential equation by some conditions. First, you can note down sometime a differential equation or differential equation which is not exact may become so on multiplication on suitable function known as IF, where IF depends on some condition. Condition number first, if del m of del y minus del n of del x total upon m is equal to fx, where fx is a lone function of x, then the IF is equal to integration, IF is equal to e to the power integration fx into dx. Now second is condition number second, if del n of del x minus del m of del y total upon n is equal to fy, where f is the only function of where fy is a lone function of y, then IF is equal to e to the power integration p e to the power integration f y dy. Now condition third, if n is the form of is the form of y is equal to y f x comma m is equal to y f x x y, and n is the form of n is equal to x f x comma y x y, then if is equal to 1 upon m dx minus n dy. This is the three condition of the reducible to the exact differential equation. First, you can note down, sorry, this is m into x and m into y. This is a first condition. Del m of del y minus del n of del x is equal to m total upon del m upon del y minus del n upon del x total upon m is equal to only function of x. Then if is equal to e to the power integration fx into dx. Now second condition is if del n upon del x minus del m of del y total upon n is a only function of y, then if is equal to e to the power integration fy into dy. Now third condition is if m is the form of m is equal to y fx f xy and is n is the form of x f x comma y, then if is equal to 1 upon m into x minus n into y. You can use this tricks or this rule, you can find the exact differential equation. Now I am continue to the some numericals related to three conditions. First you can note down, I am continue some example. You can note down first example related to the equation reducible to the exact differential equation. By the first condition, you can note down, solve the differential equation, solve the differential equation if you can note down x minus y square dx plus 2xy dy is equal to 0. Now the solution of this problem, you can note down, we have x minus y square dx plus 2xy dy is equal to 0. First, you consider to compare this equation by exact differential equation m dx plus n dy is equal to 0. Now, where m is equal to x minus y square and n is equal to 2xy. Now, you can first find del m of del y. Now, where x is constant, del of del y x minus y square, this means minus 2xy. Now 2x, sorry, minus 2y. Now again del n of del x is equal to del of del x, where y is constant. You can write 2xy. You can find 2y. 2y. Now, since del m upon del y minus del n of del x total upon m is equal to only function of x. Now, fx is equal to, you can write del m, this means minus 2y minus 2y total upon the value of m. This is, sorry, this is n. Now you can write 2xy, you can write minus 4y total upon 2xy, you can write del y fx is equal to minus 2 upon x. Now then find the if. If is equal to integral fx into dx. Now you can write integration minus 2 by x dx, or you can write e to the power log 1 upon x square. Now you can write if is equal to 1 upon x square. Now this is a equation number first. Now multiply multiplication multiple of if in equation first. Now you can write integration. You can take the integration 1 by x square x minus y square dx plus integration 1 by x square the value of n minus 2y dy is equal to c. Now you can write integration 1 by x minus y square upon x square dx minus 2 integration y by x square dy is equal to c. Now you can write log x minus plus y square by x minus 2 y, 2 upon x square into y square by 2 is equal to c. Now you can write log x plus y square upon x minus y square upon, this is the value of x, this is x, this means x, this is a plus, this is plus, this is plus, plus x is equal to c. Now you can write 2y square plus x log x is equal to cx. Now you can write 2y square plus x log x is equal to cx. This is a solution of the differential equation first. This is a solution of differential equation first. You can note down this numerical. This is a very important for your examination. This is a first condition for reducible to the exact differential equation if the differential equation is not in a exact differential equation, because it is not satisfied the del m upon del y is equal to del n of del x. The del m upon del y is not equal to del n of del x. Now the first condition is satisfied. Del m of del y minus del n of del x upon n is equal to fx, where fx is the alone function of x. Now you can note down this numerical. You can note down the second numerical related to the equation reducible to the exact differential form. You can note down second numerical related to the second condition of reduce the exact differential equation. First you can note down solve the differential equation if y x square y plus e to the power x dx minus e to the power x dy is equal to 0. Now first, the solution of this problem, we have y x square y plus e to the power x dx minus e to the power x dy is equal to 0, where m is equal to y x square y plus e to the power x and n is equal to minus e to the power x. First, you can find del m of del y is equal to del of del y, the value of m y x square y plus e to the power x, where y is constant, x is constant. Now you can write del m of del y is equal to 2x square y plus e to the power x. Now second, you can find del n of del x is equal to del n of del x, where y is constant, e to the power minus x, it means minus e to the power minus x. Since del m of del y is not equal to del n of del x, now using the second condition of the reducible to the exact differential equation, since del n of del x minus del m of del y total upon m is equal to only function of y. Now del y fy is putting the value of del n minus e to the power x minus 2x square y plus e to the power x total upon m. This is a value of m y x square y plus e to the power x. Now you can write fy is equal to minus 2 upon y. Then if is equal to e to the power integration fy dy Now you can write e to the power integration minus 2 upon y dy. Now you can write if is equal to e to the power log 1 upon y square, 1 upon y square or 1 upon y square. Now this is a equation number first. Now the multiplication of if in equation first. Now integrate m dx where y is equal to constant plus integration n dy is equal to constant is equal to c. Now the putting the value of m with multiplication of if, with multiplication of if. Now you consider this. Now the multiplication of if in the equation first and second, you can write y square y x square y plus e to the power x upon into dx total upon y square plus e to the power x, sorry this is minus y square dy is equal to 0. Now integrate both sides. You can write integration x square y plus e to the power x total upon y dx minus integration e to the power x upon y square dy is equal to constant. Now you can write x to the power 3 upon 3 plus e to the power x upon y minus 1 upon y, this is a minus minus plus e to the power x is equal to c. Now you can write x to the power 3 upon 3 plus 2 e to the power x upon y is equal to c. This is a solution of this differential equation. This is a solution of differential equation first. By using the second condition of the equation reducible to the exact differential equation. This is an important numerical for your examination. Please you can note down and watch to my video and share to the all friends. If you have any problem, please comments to my videos. Thank you.